Hi and Assalamualaikum. Today, me, Nurul Sabila and Nurul Nabila are going to talk about introduction to logic gates. The task we're given is we're given to construct timing diagram with specified input waveforms with appropriate example and generate the truth table with any number of inputs with appropriate example. So, I'm gonna start with exercise 1. As you guys can see in the circuit diagram, we have two logic gates which are and. So both of the logic gates have the same input which are A and B. The input then produce two output which are C and D. Let me explain how to get the input and the output of the circuit. First of all, as you guys can see, the input of A is 0, the input of B is 0 also, the output of C is 0, the output of N is 1 because it is completely opposite with the output of C. Next, the input of A is 0, the input of B is 1, the output of C is 0 because one of the value of the input is not 1, and the output of D is completely different with C, which is 1, because we just get 0 for the value of output C. Another example is the input of A is 1, the input of B is 1. Since both of the input is 1, so the output of C is 1. Hence, the value of output D is 0 because it is opposite with the output C. Next, the input of value A is 1, value B is 0, output of C is 0, and output of D is 1. Last but not least, the input of A is 0, the input of B is 0. This means both of the input has 0 value. So the output of C is 0, and of course the output of D, which is NAND logic gates, is gonna be 1. As you guys can see here, the truth table here is basically the same as the truth table in the slide before. So, how to draw the timing diagram and waveforms? As you guys can see here, it is drawn based from the input, output. As you guys can see here, the input of A, which is 0, 0, 1, 1, 0, is drawn like the above diagram. The below part of the timing diagram represents the 0 value of the input or output. Meanwhile, the upper part of the diagram represents the value of 1 in the output of output. As you guys can see here, 0, 0, 1, 1, 0 for input A. So the timing diagram will be lower, lower, upper, upper, and lower, lower. It is how does it works. So another example, let's see for output C example. In the truth table, the value is 0, 0, 1, 0, 0. Hence, the timing diagram will be lower, 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 upper, lower, lower. The green one, the third one from the above. So that's how the truth table and timing diagram related to each other. Next, I will pass to Nurul Nabila.
In exercise 2, we are analyzing combinational logic circuit made out of 3 logic gates or NOT and AND. The goal is to understand how the output set respond to different combination of 3 inputs, A, B, and C. First, inputs A and B go into an OR gate producing A plus B. Simultaneously, input B pass through a NOT gate to produce NOT B. Then C and NOT B go into another OR gate producing C plus NOT B. Finally, both OR gate outputs are combined using an AND gate, which is Z. Let's take a look at the table. At the first moment, C A is 0, B is 0, C value is 0. From the truth table, the output Z is 0. That means for this combination, the logic gate gave us a low output. Then let's take a look at row number 4. A value is 0, B 1, C 1. From the truth table, the output Z is 1. That means for this combination, the logic gates give us a high output. Then let's take a look at this diagram. This diagram shows the relationships between the three input signals A, B, and C, and the resulting output Z. Each line in the top part is a waveform, which tells us when each signal is high or low. The output signal Z changes based on a logic circuit, which we analyzed earlier. By comparing the waveform and the truth table, we can verify that the output Z changed correctly based on the inputs. This kind of timing analysis is important in digital systems to make sure circuits respond at the right time.